Hello there, and a very big welcome to you joining us live for the launch of 3 satellites from the Guiana Space Center. In South America, we're here in Paris. There on the pad, we have 2 telecommunication satellites and 1 mission extension vehicle, which is very exciting new technology. Now, we're starting the program, we believe, with a red status panel. I'd like to introduce you to Stefan Israel, who is the CEO of Arianespace, the company launching the satellites. Thanks for being with us, Stefan. As I said, we're starting with a red status panel, and it would seem that Mother Nature is not being very kind to us at the moment.
Yes, so you know that to be ready for a launch, you need basically 3 things. You need the launcher to be ready, and up to now, the launcher is perfectly ready. You need the satellites of our dear customers to be ready, and they are ready, but you need also to have the weather on your side. And up to now, we do not have the weather on our side, so we will have to wait a little bit during the launch window to see whether it turns out to be green, but now it's red.
So just to explain that, we have a launch window tonight of about 47 minutes. A launch window, of course, is the time during which we can launch. We hope to launch at some point during our launch window tonight, and so fingers crossed for the weather. Stefan, tell us about our satellites. We've got 3 on board.
Yes, so we have 3 satellites on board, which is very unusual because usually we have 2 satellites on board, and tonight we have 3 satellites on board. In the upper positions, we have Galaxy 30 for Intelsat. We have MEV-2, which is a mission extension vehicle for SpaceLogistics LLC, which is a subsidiary of Northrop Grumman. And in the lower position, we have BSAT-4b and Maxar. BSAT-4b is a Japanese operator. And you know that we have very, very long-lasting relationship with Intelsat. First Intelsat satellite was launched in 1983 and BSAT in 1997. So an old story between us.
And that's one of the wonderful things about space, isn't it? Is the great relationships that develop over many, many years. Now, what's been happening in recent days?
Yes, so you know that a few days ago we have had to change a sensor which is inside the liquid hydrogen tank of the main stage. We have made this operation on August the 7th. It has been done perfectly well, and so we have made the transfer of the launcher on the launch pad 2 days ago.
Okay, well, let's see if we can go over now to the Guiana Space Center, because, of course, as I said, Stefan and I are in Paris, and in the Guiana Space Center, we can actually see there is the Ariane launcher on the pad. It's an Ariane 5, the heavy lifter of the Ariane family of launchers, and this is the launch Mission Control Center, and this is Luce Fabregat. Luce, thank you very much indeed for joining us. Are you able to give us any more information on the situation tonight?
Yes, pleased, Katie. Here we are in the flight directorate, the flight desk, where we are 4 of us for tonight. Roland Lagier, our highest technical authority at Arianespace, CTO. Bruno Gérard, who is heading the Arianespace teams here in French Guiana, fully connected with local authorities, and on communication aspects with us, Martin Studer, and we will have this flight desk tonight. We will have the final say and the decision to go or to postpone. As was explained by Stefan, you can see that.
Sorry, I interrupted you, Luce, and I didn't mean to. I was going to say, obviously, very responsible job. I think you were going to go on to tell us the latest.
Yes, as was explained by Stefan, in fact, we need 3 entities to go, the satellites, and they are here in front of us. The customers are there, ready to go. The launch vehicle with its ground segment is also clear and green tonight. And as you've seen, we've got, on the big screen in front of us, we've got a red on the Meteo side. As you know, 5 hours ago, before the launch, 5 hours before the H0 that was targeted, we took the decision to fill the launch vehicle. At that time, we took this decision based on the weather forecast for the H0 for 6:33 p.m. That is local time for the opening of the launch window, based on the models we have on the weather forecast for this H0. After that, we had a balloon, a new balloon. We had the balloon also in the morning, but we had a new balloon around 3 hours before this targeted H0, and this balloon gave us an information that winds in terms of direction and in terms of levels were not favorable for launch at the beginning of the launch window at 6:33 local time. So we decided to have a new balloon, and this new balloon was launched a little more than 1 hour ago, and its data are being processed now, and we will have the results for these balloons in a few tenths of minutes, and that means we are no more in a position to target the beginning of the launch window, 6:33 p.m., and so the operations will go on, and we will stop the operation on the launch vehicle on the ground segment at -7 minutes before the launch. That is the beginning of the automated sequence, and at that time we will stop the countdown, and we will wait for the information coming from this new balloon, for the last balloon of -1:30 minutes, 1 hour and 30 minutes, and based on this data, we will decide to go or not. And that means we will not target the beginning of the launch window, as I said, but we will target a new H0 at 7 p.m. and 4 minutes.
Luz, thank you very much indeed for taking the time to explain that to us. So just to recap, we are waiting now for the synchronized sequence, which starts at -7, for the countdown to stop at that point, which is what we are expecting to happen. Waiting for the range operations manager.
À tous de DDO, arrêt du décompte suite à un rouge lié aux conditions météo. Que tous les moyens restent prêts pour la reprise de la chronologie à 0-7 minutes en cas de retour au vert.
Okay, so the range operations manager, just to translate that for everybody who doesn't speak French, has announced that we have a new launch time fixed, which is 7:04 Kourou time. Is that correct?
Yes, so as explained by Luz, so we are now going to monitor the weather, and if there is a positive evolution, which can happen, then we should be ready for a new launch slot, which should be at so in Kourou it will be 7:04, and the decision will be made 10 minutes before. So I think we will come back 10 minutes before 7:04 to see how the situation is evolving, and if this red turns out to be green, which would be positive. Otherwise, we will wait up to tomorrow.
Okay, thanks very much indeed for that, Stéphane. So just to recap on those times that Stéphane was saying, so that's a new launch time of 7:04 in Kourou, in French Guiana, and that is a launch time of 10, I believe, 04 UTC, Universal Time. So we're going to come back to you 9 minutes or 10 minutes before that at around about 5 to 10 in the evening, Universal Time. That's about 5 to 12 in Paris. And we will see you back here then. Please come and join us.
Thank you.
Hello again, and welcome back to our live program. We have 3 satellites on the pad at the Guiana Space Center waiting to lift off. They are Galaxy 30, MEV-2 and BSAT-4b. Now, we had to put the countdown on hold because we've had a weather issue. As we were saying earlier, Mother Nature hasn't necessarily been too kind to us, but Stefan Israel is joining me. And Stefan, I have to tell you that when we look at the pictures of the launcher on the pad, which maybe our director can show us some pictures of the pad, it doesn't actually look like the weather's particularly bad out there.
Yes, but you know, you have 2 reasons not to launch due to weather conditions. The first one is when you have storms, and this you can see it. And the second one is when you have negative high altitude winds, and unfortunately you do not see it. But look at the screen, the meteo is now green, so we can go tonight.
So that's good news. So we've got a new launch time, and there you can see the launcher. So on the pad, the Ariane 5, the heavy lifter of the family. Our original launch time was 6:33 Kourou time. That's 9:33 Universal time. And you can see there.
Suite au retour vers des conditions météo, le nouvel H0 visé est 22h04:00 TU. Je répète, le nouvel H0 visé est 22h04 TU. Le temps décompte redémarrera à 21h57 00 TU.
Good. That means that the Range Operations Manager has now announced that everything has gone back to green, and we have a new launch time, which is 10:04 Universal Time, which I believe is 19:04, I think, in Kourou, in French Guiana. So that's good news.
That's great, yes, that's great.
So I'm going to let you go now, Stefan, and head back to your teams. Thank you very much for joining us. We hope to see you later. Thank you, Stefan Israel, ladies and gentlemen. And I'm going to introduce us now as well to Damien Gilles, who is an expert who's going to be joining me for the rest of the programme. Damien, thank you very much for joining us. Do take a seat. So, Damien, let's just talk about the status panels, because we could see those status panels on the screen.
Début de la séquence finale lanceur.
Sorry? So, I didn't quite hear him there, but I believe that we've now started the synchronized sequence. So that's good news. The synchronized sequence being the last 7 minutes of the countdown. This is the automated sequence when everything's happening automatically. And you can see the status panels there, Damien, on the left-hand side of the screen.
You have there the status panel, where all the subsystems coming from the launch base, the launch range, the launcher, and the customer give their status towards the mission control center. And it's like a traffic light. If everything is green, it's a go. If it's red, you should stop.
Obviously, and the red status panel means that one of the systems across the base is requesting that the countdown goes on hold. And of course, now our countdown is back on track. So we have a number of different teams in the control center. We have the program managers, who are some of the teams who work closely, aren't they, with the client? What do they do?
Exactly. They are the sole contact between Arianespace and our customers. As you know, the customer is very important for Arianespace. That's why we dedicate people that are the single interface, and they work very closely with the customer. Nearly 3 years for these missions, for both customers. And you can see there on the screen, Marie-Laure Chauffour with the interface for Galaxy 30 and MEV-2.
Indeed, working hard there and working closely on her phone, talking to customers, no doubt. Now, we are using, as we said earlier, the heavy lifter of the Ariane family. It's Ariane 5. She's a big, powerful beast, and she's going to lift, hopefully, our satellites into space. What happens after launch?
The booster ignition triggers the liftoff of the launcher. Shortly after, the launcher performs a pitch maneuver in order to get into the required direction. The boosters are separated roughly 2 minutes after liftoff, and then we separate the fairing when it is not needed anymore to protect the spacecraft from the atmosphere. The main stage engine switches off when the launcher detects that the intermediate orbit is to be reached. This event is called injection. The main stage then falls down into the Atlantic Ocean, and the upper stage engine switches on and will carry our satellite up to their injection orbit. During this path, the satellite flies through the atmosphere, which is thin but very fast. It generates aerothermal flux. The upper stage switches off when the final orbit is reached. It marks the beginning of the ballistic phase, where we will separate our customer. First, Galaxy 30, then MEV-2. Before releasing BSAT, we release the SILDA, the dual-launch black structure that you can see. And finally, the release of BSAT-4b. The launcher completes its mission with the start of the passivation, and from now on, the teams from the Spacecraft Mission Control Center take over and perform all the maneuver up to the final destination of the spacecraft.
And of course, Galaxy 30 and BSAT-4b will be travelling to their final orbit in space, which is in geostationary orbit. But MEV-2 has got a slightly different job, hasn't it?
Yes, MEV-2 is really a different vehicle because instead of going to a predefined location in the geostationary orbit, it will dock to another satellite and will perform all the maneuvers that are required to maintain this satellite in position. And so it extends the lifetime of this customer.
It's really incredible and very, very exciting technology. This is the second time we've done it.
Exactly, yes.
Yeah, so it's really, really wonderful. So the computers on the ground will have now given the launch time to the computers on board. So prior to that, the launcher didn't know what time it was actually lifting off. And if you look at the top of the vehicle, you can see, we call them the cryogenic arms, those structures clamping onto the top of the vehicle, and it's pumping cryogenic propellant in. That's liquid hydrogen and liquid oxygen stored at very, very cold temperatures.
Yes, because we need to get them liquid, and so the temperature for the liquid hydrogen is minus 253 degrees, and for liquid oxygen, minus 183 degrees. And they are so cold that they evaporate, and we have to topping up continuously up to the final moment. And we disconnect the cryotechnic arms 6 seconds before H0.
So you'll see that happening just before launch. Another thing to watch out for is the fact that we switch the engines on the main stage, the Vulcan engine,
attention pour moins 1 minute.
7 seconds before the boosters.
Top, à 0 moins 1 minute.
We are 1 minute to launch. We're live at the Guiana Space Center for the launch of Galaxy 30 and MEV-2 for Intelsat, and BSAT-4b for BSAT, Maxar, and everybody in Japan. Our very best wishes to all the teams now as we sit back and watch the launch. Good luck, everybody.
À tous les DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. L'image Vulcain, l'image VAP. Décollage. La propulsion est nominale.
And we are off. Galaxy 30, Mission Extension Vehicle 2 and BSAT-4b have started their journey. He's telling us that the trajectory is normal. And we've broken the sound barrier, Damien.
Exactly. We are now traveling faster than the speed of sound, which is equal roughly to 1,200 km per hour, and the speed will continue to increase in the coming seconds.
And look at that. Ariane 5 is blazing a trail across the night skies at the Guiana Space Center, heading out over the Atlantic. Everything's going according to plan. Right now, we are using the boosters to get us away from the gravity of our Earth, aren't we? They're doing all the work.
Yes, they are doing most of the job because they provide roughly 90% of the thrust today. It is equivalent to 13 jet engines for each boosters. And their job is really to push us away from ground and to provide sufficient velocity to the launcher. And we need a lot of energy to do that. Each booster burns 2 tons of propellant per second.
That's an awful lot. And if you look at the right-hand side of the screen, what you could see there was our distance from the pad. You could see our speed or velocity and our altitude. And you'll see it again in a minute. We can see the trajectory, which is the planned trajectory. There it is on the right-hand side of the screen. Our planned trajectory, and the white cross is the actual position of our launch vehicle. He's telling us that everything's going normally, and at the top of the screen there you can see our flight path. We are now losing the boosters. They have done their job, they've burnt their propellant, we don't need them anymore. The lighter we are, the faster we go. And if you look at the front, the top of the vehicle, that section containing the satellites, we call it the fairing. What's its job?
Its job is to protect the satellites from the outer world. First, at liftoff, because the liftoff generates a lot of noise, so it protects the satellite from this noise. And during the atmospheric flight, it protects the satellite from the friction with the atmosphere, which we call the aerothermal flux.
If you look at our altitude, you can see we're 100 kilometers above our planet. That means we've crossed the border with space, often known as the Kármán line. Getting closer now to being able to eject our fairing. That's what it looks like because we don't need it anymore, Damien. We're in space.
Exactly. The effect of the atmosphere is now very low.
So we don't have enough thickness in the atmosphere for friction to bother us. And we can see our satellites for the first time. At the front there, you can see Galaxy 30 and MEV-2. And then there's a black structure. That's called the Silda. And inside that is BSAT-4b. You can't see it right now, but hopefully we'll see that later. You're getting information in your ear, aren't you? The Range Operations Manager's hearing it, and you're hearing it too.
Yes, I have a direct link with people located near the launch pad. They are located in Gallio, a few kilometers away, and they receive directly the telemetry from the launcher and gave all the confirmation and all the status, and the range manager receives exactly the same information.
And at the Space Center, the Range Operations Manager is responsible for calling that out to everybody. Our flight path takes us out across the Atlantic. We're traveling along the equator. We have a number of tracking stations along that flight path, and they pick up the signal. You can see our flight path there. They pick up the signal from the launcher as it flies over. Is that right?
Exactly, and we have a network of stations which are located all over the flight path. The first one is located in Gallio, which is a few kilometers away from the launch pad. It will cover all the beginning of the flight up to the main stage flight. We have then Natal, located in Brazil, which will cover part of the main stage flight. And then we have the next station, which is called Ascension, which is located in the South Atlantic. And we have in a gap, what we call a telemetry gap between Natal and Ascension. It means that we have a loss in the visibility, but this is completely nominal because we foresee it, and we do not lose the data because we record them in the onboard memory, and we download them when we are back in visibility. The next station is Libreville, and we have exactly the same phenomenon between Libreville and Ascension, where we have a telemetry gap, which is exactly nominal. And at the end, we will be in direct visibility of Malindi, which is located in Kenya. And Malindi will allow us to follow the end of the flight and in particular the ballistic phase, where we will have the separation of all our passengers.
Thanks very much indeed for talking us through that, Damien. So that's the last station you can see there on the film, Malindi in Kenya, and the guys and girls there will be tracking the separations. Joining us now in the studio is Raphaël Chevrier. Raphaël is a business developer at Arianespace. Thanks very much indeed for being with us, Raphaël. That means part of your job is very much looking to the future, thinking about future technologies and innovation.
Yeah, absolutely. And actually, if you think about it, like only 6 decades ago, we've been launching the first spacecraft in space. And in the meantime, we've been sending humans on the moon, spacecraft on Mars, on asteroids and beyond. And so a lot has happened in 6 decades. And today, we are launching satellites for telecommunication, internet, navigation, Earth observation. So you can see that space is really part of our daily lives. And that's very evolving a lot.
Absolutely. And the people who are making that happen are there right now. We're looking at various important people there in the Guiana Space Center. Who are they and what are they doing?
Here we can see the people from ESA, the European Space Agency. And these people are currently monitoring the overall status of the launcher to check that it was inside the qualified domain. So here we see the head of the ESA office in Kourou.
All these teams very important, getting the scheduled moment here for the acquisition of the signal, picking up the signal at the tracking station in Natal, in Brazil, one of those tracking stations that you mentioned to us back there. And there we have the confirmation there from the range operations manager that we've picked up that signal. Raphaël, and he's telling us, just a translation for everybody, that everything on board is going according to plan. Raphaël, given that the launcher operates remotely, why is it important for us to have the tracking stations?
Well, it's very important for, I would say, 2 main reasons. The first one is safety. It's always safety first when it comes to launch satellites in space. So you really need to make sure that you have visibility of over the whole launch sequence, and especially in dynamic phase of the launcher. And so, you really need to know how to react if something happens. And then the second is you collect data, and then you can know more about your launcher for the next launch.
And we have separation there of the main stage and ignition of the upper stage. This is very much now the next phase of our journey. And the range operations manager has confirmed that we have the upper stage engine switched on. The upper stage is a very important piece of kit. Its job is to deliver our satellites into space. Damien, whereabouts has it got to take them?
Exactly. It will deliver our customers to an orbit that we call a geotransfer orbit. The geotransfer orbit is particular in the sense that it is elliptical, so it's like a shape of an egg. You have the short part, which we call the perigee, which is located close to the Earth, if we have an ellipse. And the highest altitude point, which we call the apogee, is the apogee of the GEO orbit, which is 35,786 kilometers. And this orbit is really important for our customers.
Yeah, I mean, GEO orbit has been used intensively to launch telecommunication satellites mainly. And it's very also important because the satellite stays on the fixed point is like following the rotation of the Earth. It's like when you are like holding your child's hand on a roundabout, then you're staying at the same position with respect to your child when your child is turning around. So it's very important that you can deliver services daily, like 20 hours a day.
And right now we're looking at a replay. This was 10 minutes and 28 seconds ago. We lifted off from the pad at 7:04 French Guiana time. That's what it looked like. It was a really beautiful launch. It was incredibly impressive. I always feel a bit sorry for these guys because they have to watch the launches on screens, whether you're in mission control or whether you're in launch control. Have you seen launches in real life?
I had this opportunity once, so it was really impressive. This is a moment that I will always remember, because you are impressed first by the power, because you really feel the power of the launch. And then you see the light, which is really impressive, and the noise generated by the launcher. So even if you know how it will work, nevertheless, you are impressed when you leave it alive. And this is really something that you will remember for years. And I guess it was the same also for you, Raphael.
Yeah, it was pretty much the same. Like, I remember the bright light and the sound coming from the ground. That was very impressive. And I also remember that I was really hesitating between like taking pictures with my phone or leaving the moment. And I quickly put my phone back to my pocket and lived the moment, because like the images are like just breathless, really.
Yeah, it's a really exciting thing, and you actually feel the vibrations as well, which is quite impressive, isn't it? And of course, Ariane 5 is the biggest of the family of launches here. She's incredibly big. And Raphael, today she's more efficient than ever. Just very, very briefly, tell us why.
Yeah, it gained over the years, 2016, 300 kilograms of performance. So DNA is part of innovation is part of our DNA, and we continuously improve the performance for the customer's benefit.
Absolutely. Let's go and watch a film now and see what those improvements involved.
Well, for the Ariane 5 performance increase, we've introduced the so-called Performance Increase Competitiveness Program, which is mainly addressing two axes. The first one is elongating the tanks to put more propellant inside. This is in the ESC part. But secondly, we were elongating the equipment bay, the VE-BH, to enable much more payload inside the Ariane, and introducing also a more innovative membrane, which will also be used in the future in the Ariane 6. Soon as we finished PIC, we had to start with PIC because the market was demanding much more performance. It was basically increasing the space below the CILDA, the so-called double seat adapter, increasing the space in the cone, and last but not least, lowering the apogee to also serve the sub-GTO. With all these measures, we gained additional 500 kilograms of performance. The philosophy for Ariane 6 is a totally different one to Ariane 5. Of course, we build up on our heritage of the Ariane family, but for Ariane 6, we use the modular design from scratch to make it versatile and scalable for all customers and the fast-evolving market. Among all the different things we have at stock, I would like to mention Icarus, our innovative carbon Ariane upper stage, fully made for performance jumps into orbits which we have not visited yet. For example, the cis lunar orbit. And these are topics which we have in our pipeline, thanks to all of our good engineers, our excellent teams, which make it happen. Thank you to all of them.
Well, now, during that film, we picked up the signal. We've heard from the range operations manager there telling us that everything's going normally on board. We will have picked up the signal
from Ascension again.
From the tracking station in Ascension Island, which is in the middle of the Atlantic Ocean. Damien, how does... Well, I was going to ask you, how does Ariane know about where she's going? But we're going to watch a film about the vehicle equipment bay.
Embedded software. What is the biggest challenge for developers? What exactly is embedded software? It's the brain of the launcher. It is set for each flight and allows the rocket to navigate independently once the engines have been started. All the phases of the mission are programmed within it. It controls the smooth progress of the flight and is ready for any events that may occur. It reacts accordingly and adjusts the launcher's actions in real time. It is placed in the equipment bay, right at the top of the launcher. It usually takes between 5 and 10 years and a team of 100 people to develop it. Just to recap, the embedded software is able to send a 750-ton rocket into space to analyze and respond to all eventualities, and all this with complete autonomy. Not bad, is it? But that's not all. Once in space, the launcher and its software are no longer protected by the Earth's magnetic field. Without adequate protection, solar radiation would damage them. So the engineers have designed dedicated electronic circuits to withstand this extremely hostile environment. And that's how you fly a rocket into space, through solar radiation at 8,000 kilometers per hour.
Well, when you see such an extraordinary advanced technology, it's no wonder that people from all over the world watch our launches. And we've been asking you to write in on social media. Everything's going well. To write in and ask us your questions. And the guys here have done a little triage and picked out a few questions. I'm going to start with you, Damien. A lot of people have asked us about the new rocket which is being built, Ariane 6, and a lot of people are really keen to know, will she be able to carry people?
Well, the first step, of course, is reliability, because if you want to carry people, you need a very reliable launcher. And reliability has always been of utmost importance for Ariane family of launchers. It was the case, of course, for Ariane 4, and then in Ariane 5 again. For Ariane 6, reliability will be, of course, a key requirement. And I would like also to recall that for Ariane 5, at the beginning of the project, we have a project named Hermes, for which we were supposed to carry people. And this is why we have a really reliable, redundant launchers in terms of reliability.
Yeah, and Europe also developed pressurized modules. So I agree with you, Damien, that Europe has everything needed to do that. The experience, the technology, and as a matter of fact, this market is getting stronger and stronger. I mean, right now, astronauts are going to the International Space Stations. Tomorrow they will go to the moon very often. And we know that our European astronauts take off from Russian launchers, tomorrow maybe, probably from American launchers, but just imagine what the emotion it would be to see a European astronaut taking off from Kourou. It would be just amazing.
It would be fantastic, wouldn't it? It would be really wonderful. Just a quick note to say that we've picked up the signal at the tracking station, the Libreville tracking station, which is on the west coast of Africa. Now, our first passengers to be released are Galaxy 30 and MEV-2 for Intelsat.
Le pilotage est calme. Tous les paramètres à bord sont normaux.
It's a pleasure to be with you today to celebrate the launch of our newest satellite, Galaxy 30. I want to start by thanking two long-standing partners for their ongoing commitment to Intelsat's success. Arianespace, with our 62nd launch together today, and Northrop Grumman, which has manufactured 11 Intelsat satellites. It's an especially exciting launch day for us at Intelsat because Galaxy 30 shares a ride to space with Northrop Grumman's second mission extension vehicle. Our Intelsat 1002 satellite will be the very first customer of MEV-2 services next year. We were proud to partner with Northrop Grumman on their historic MEV GEO orbit servicing mission earlier this year, and we look forward to pioneering this second mission with them. Thank you to the Intelsat planning, engineering, and operations team who have been passionately involved in the Galaxy 30 and MEV-2 programs. There's also a deeper purpose and significance to these launches. Every new Intelsat satellite in space means that we're able to connect even more communities, businesses, and governments, and in turn, to empower even more people with life-changing connectivity and communication services. Galaxy 30 is Intelsat's first satellite to utilize 4 frequency bands, with C, Ka, Ku, and L-band services. It will play a key role as part of our C-band cable distribution neighborhood in the United States. It will also serve network, enterprise, and government customers with its extensive coverage of North America, including a hosted payload for the Federal Aviation Administration in conjunction with our partner Leidos. Thank you, enjoy today's launch, and go Galaxy 30 and MEV-2.
Every satellite launch is important for us. Our satellites are our assets in the sky. This particular launch replaces one of our very key video neighborhoods for our media customers over North America.
My name is Pascal Fromont. I'm the Director for Product Management of our Media Business Unit here at Intelsat.
Galaxy 30 will be there to enable this richer, higher quality content to reach the viewers and to keep entertainment, news, and sports reaching homes at its best quality in a way that is hyper reliable, always on air, ready to be consumed.
This launch is not your typical launch. Since the launch of our first satellite back in April 1965, so that's 55 years ago, Intelsat has launched 150 satellites. This is the 151st satellite that we launched. But it's actually the very first satellite that has 4 different frequency bands. It will enable a slew of new applications. It really takes a village to design, build, test, launch, and then operate the communication satellites.
It's really amazing how we pull together these different organizations with a common goal. We all really enjoy this kind of work. We get on the console at launch minus 10 hours. And once they ignite those solid rocket motors, it's 100% commitment. So you go through this wave of anticipation, worry, calm, and then relief. And then we open the champagne at the end when it's successful here in French Guiana.
We're here with a mission. We're here to connect people around the world. It's really a very inspiring business to work in.
And Galaxy 30 and MEV-2 are the 22nd and 23rd satellites that Arianespace is orbiting for Intelsat. Pretty impressive. We are coming up to the acquisition time for the tracking station in Malindi. So wait. Okay, we have that tracking station. So they're now following our launcher. Back to our questions from our viewers. Raphael, Lucy has asked us, is Europe planning any missions to the moon or Mars?
Well, I will start with Mars because it's a very good timing to ask these questions, because 2 weeks ago, as you probably know, there is this Perseverance spacecraft that developed by NASA and took off from the US. It's going to Mars, it's going to the surface, it's going to grab samples there. And 6 years after that, in 2026, there is another spacecraft developed by Europe, which will take off, go there, grab the samples in orbit, in the Mars orbit, and bring it back to Earth, and it's going to be in 10 years from now. So this is a good example of long-term cooperation in space.
Yeah, no, it is, and it's incredibly exciting, and these are really inspirational and wonderful missions, aren't they? So we have another question, actually, the same one for you, Raphael, because Juanita is quite a related question, has asked us, are you working with other space agencies like NASA, for example?
Oh, absolutely. I mean, we are working, like Europe is working with almost all national space agencies in the world. And, well, talking about NASA, just to give you an example, next year, Ariane 5 will launch a very important project. This is the James Webb Space Telescope. A lot of people are waiting for this to be in space. It's going to go at 1.5 million kilometers from here. And it's going to observe the deep space, for example, stars or galaxies that have been formed right after the Big Bang. So it's a very major project, and there are many, many more projects that are made in cooperation.
That's incredible. This is going to be giving us even more remarkable information than James Webb. So that's very, very, very exciting.
And we'll have a lot of pressure on our shoulder on this.
Sorry, I meant even more information than Hubble. I meant to say, yes, of course. So this is the scheduled upper stage cut-off time for our engine of our upper stage. So we are on altitude. and at the right speed, and we are now going into the ballistic phase, Damien?
Yes, we have a nominal confirmation for the shutdown of the upper stage engine.
So that's good to know. Ballistic phase means that we're traveling without propulsion. We're cruising without the engine, and we're entering into the next phase now. Just very briefly, let's go back to some of our questions, because somebody wanted to ask, Wesley actually has asked, Damien, this is one for you. What advice would you give to young people wanting to get into the space business?
Well, first, you don't have to be part of the space business or being part of our domains today to join the space community. Because if you are working as a computer scientist, as a manufacturing engineer, electrical engineer, orbital mechanics engineer, structural engineer, whatever, we need all types of engineers and technicians to work. And we have several places where people can join the space community. We have industries like ArianeGroup, you have Arianespace, like for launch service provider, and we have also the space agencies, CNES for the French Space Agency, ESA, and we have also International Space Agency where we can work if we need.
Yeah, and space is not just about engineers. There are lots of jobs in space. Commercial, communication, lawyers, and etc. But one thing is certain is that when you join the space sector, you become very quickly part of the family and very quickly passionate about space.
And this is indeed one big family. We can see here at the Guiana Space Center. Who are we looking at, Damien? Are these the Galaxy 30 teams?
Yes, we are looking at the operational team who have worked very hard in the latest day to complete the preparation of their spacecraft. And they are now waiting with eagerness the separation of their spacecraft, which will be like a birth for them because the spacecraft will be ready and will complete its journey on its own.
And this is what it looks like up there, that berth that you talked about. This is the scheduled separation for Galaxy 30.
Séparation Galaxy 30.
And we have confirmation there from the Range Operations Manager. Galaxy 30 has now started its new life in space. It's making its way away from the mothership. There you have it, successful separation. Good news for our customers, right?
Very good news. A very good step for the customers.
And the space ballet continues, of
Yes,
course.
this was an important milestone, and the maneuvers will go on in order to prepare the separation of the next spacecraft.
So our next satellite to be released is MEV-2, and it was also supplied by Northrop Grumman for SpaceLogistics. Let's find out a little bit more.
Hi, I'm Joe Anderson, Senior Director at Northrop Grumman and Vice President of SpaceLogistics LLC, a Northrop Grumman company. Earlier this year, our first mission extension vehicle, MEV-1, made history when it docked with a satellite running low on fuel, the Intelsat 901. Now IS-901 is back in service thanks to our innovative technology that gives satellites a new lease on life. Our low-risk docking system keeps the customer operational and extends the lives of useful satellites. Once our services are no longer needed by the customer, the MEV is able to undock with the client satellite and continue on to our next customer. Today, we are ready for the launch of our second MEV, which will perform its first docking with another Intelsat satellite, the IS-1002. On behalf of Northrop Grumman and SpaceLogistics, I want to thank Intelsat and Arianespace for being trusted partners on this innovative mission. Finally, we have a short animation that shows the MEV-2 mission in more detail. Go Ariane and go MEV-2.
Oh, it's pretty impressive stuff. It really is, isn't it? And the first mission extension vehicle actually docked with that was MEV-1. That was launched on board a Proton rocket in October 2019, and it docked with Intelsat 901 in February 2020. So that was this year. And I mean, it's really exciting, isn't it?
Yes, this technology is really amazing. As you have seen in the film, it combines several innovative technology. First, you have to ensure a rendezvous with the customer. To get that, you have to get close to the customer, to the spacecraft. You have to check its attitude, its angular rates, in order to be sure that you will be in a position to dock to it. And then you have to get very close to it and dock to it. So we have several very critical technologies, the rendezvous one, the docking one, and then it opens also a new business because you open a business where you can extend the lifetime of the spacecraft, and you even can put it into another orbit. So you can imagine several types of business. And one particularity to be noted for MEV-2, which is a difference with MEV-1, is the fact that it will dock onto its customer satellite directly into the geostationary orbit and not onto the graveyard orbit, because MEV-1 was completely successful. So it will gain energy, and this is really an important milestone for this new business.
Yeah. It really makes sense if the market is still there on Earth to give an extra push for 5 years, and the satellites can deliver services for such 5 years. So it's very important. And in the future, we are hoping to see like even more advanced activities of such MEV satellites, such as satellites refueling, satellites repairing, and even like satellites deorbiting. So the satellite doesn't have to go itself to a graveyard orbit. It can ask for such a service, and that's a very, very advanced technology.
And here we can see here the teams at the Guiana Space Center. Who are we looking at here, Damien?
We are looking at the MEV-2 operational teams, who are also in charge of the Galaxy 30 in Guiana Space Centers. And they are awaiting for the separation of their spacecraft.
Which is coming in the next few seconds. And there you have it. This is the scheduled moment for the separation of MEV-2.
Séparation MEV-2.
And we can hear there, we've had the confirmation?
Yes.
So that's good news. MEV-2 is now on its orbit and separated, pushed away via springs there. And we can see the Northrop Grumman Mission Operations Center there. What are they doing? They're taking control of their satellite, aren't they?
Yes. First, they have monitored the status of the spacecraft during all the launch. And now they are taking control over the spacecraft. And they will work continuously during the coming days in order to prepare the journey up to the final location for MEV-2. So it will include deploying antennas, deploying solar panels, and performing all the required maneuvers in order to get to the required positions and circularizing the orbit.
And we still have, of course, BSAT-4b attached. It's hidden at the moment underneath what we call the cylinder. I just want to go back to our questions because we've actually had somebody who asked just a quick response from you about the cylinder. Tony asked, how can the cylinder be ejected without damaging its satellite?
Okay, so to be very short, there are two major points. First, the separation system is made of 8 springs. So these springs provide energy to the part of the cylinder which is jettisoned. And when we need it, if the lower spacecraft occupies a very huge volume, we can tune the balance of the cylinder in order to avoid it from tilting during the separation. And the process lasts roughly 4 seconds.
So we've talked a lot, Raphael, a little bit previously about how things are changing in space, but you really do know the satellite markets very well, don't you? How have spacecraft been evolving recently?
Well, to make it short, basically we see many constellations of satellites in low Earth orbit dedicated to bringing internet, high-speed internet. The plan is to connect everyone and everywhere. And even like things like planes and trains and boats, moving things like this. And we also see more constellations dedicated to Earth observation. And these are very important for monitoring the climate change. And it also serves some new digitalized sectors, such as agriculture, building, rescue services, and also very small businesses, such as counting empty spaces in parking lots, for example.
Oh, that's an interesting one. Very useful. So you can have a quick look on your app to see if there's an empty space. Yeah.
Why not?
But we've also seen traditionally that we've been launching a lot of geostationary satellites. Are they changing as well?
Yeah, of course. First, we see that electric propulsions, instead of chemical propulsion, sometimes tend to reduce the size and the mass of the satellites. So this is changing. These satellites are also more flexible. It means that they can deliver several services at a time, and that's also more powerful for them. This is going to be the case for the satellites that we are launching today, delivering broadcast services with unprecedented definition, so like very powerful satellites. And of course, we are hoping to see more MEV missions doing very impressive. For me, this is very futuristic, this kind of docking to a satellite and pushing it to the correct orbit for more years.
And of course, you're going to have to, you're adapting your launch vehicle to cater for these different shapes and sizes of satellites.
Of course. If the satellites are getting flexible and more diverse, then we need to be flexible as well. So the launcher needs to be able to launch satellites anywhere, in any orbit, anytime. And so with Ariane 6 and Vega C, our next generation of launch vehicles, they will be equipped with a reignitable upper stage, allows you to bring any type of satellites anywhere. And for this, we also develop carrying structures, specific carrying structures, in order to offer ride shares, and that's very important for this.
Very important for these markets, and we'll be seeing a lot more of those in the future. Now, I'd like to go over to Japan, if we can, to Kiyoshi Takamatsu, who is the head of the Arianespace office in Japan. Kiyoshi, I think it's good morning, isn't it, rather than good evening? What time is it there?
Yes, then here it is a good morning in Tokyo. The Kuru is just on the opposite side of the Earth, so that the time difference is just 12 hours. So it's the same time than 7:44, but it is in the morning, and we are 12 hours ahead, so that we are now on the Sunday, August 16.
And where are you exactly, Kiyoshi?
Yes, and I am at the customer BSAT headquarters on the third floor. I'm at an office of the President Inoue. I will try to show him.
We can see everybody there, Kiyoshi. Looking good. Lots of waving. Hi, gang.
Can you see that? Yes, the gentleman, you can see is the President Inoue of the BSAT. So he's not alone. He is with the expert of the BSAT. And today is, and as you know, that's a very important milestone for the BSAT, Maxar, and Arianespace. And all of them, the BSAT is now the congratulation of the nominal separation of Intelsat and G30 and MEV-2.
How many satellites has Arianespace actually launched for Japanese operators, Kiyoshi?
We have launched the 31 satellite until now, and then soon it will be the 32. So that this is a good score. We captured about the 75% of the Japanese market. And also that BSAT is a very loyal customer for us. They have launched all 10 satellites with us, including today's BSAT-4b.
Well, let's hope, Kyoshi, that in a few minutes' time you will be able to all drink a glass of champagne. It will be an early one, though.
Yes, then it will be a little bit early, but then today is on Sunday, so that then after the Ariane complete its mission, we will do our best.
Very good. Thank you very much indeed for joining us, all of you from the BSAT offices there, and our best wishes to all of you. Thank you. So, as we know, Maxar supplied BSAT-4b. They have a very long history of expertise of building all kinds of satellites. We're going to watch a film, and that's going to be followed by an interview which I conducted a few days ago during our previous launch show. So let's find out more now about Maxar. Well, joining me now is Paul Este, who is the Vice President of Customer Relations at Maxar Technologies. Thanks very much indeed for being with us, Paul. Just give us a little bit of information about the structure that the satellite is built on.
Yes, the BSAT-4b satellite is built on our 1300 structure, which is our heritage structure. We've used it for all of our geocommunication satellites for many decades now. Whether the service is direct-to-home, such as the BSAT satellite, or it's fixed satellite services, or mobile, or including direct audio radio, which we do for SiriusXM. We are also adapted the 1300 structure for a planetary mission. We are sending the structure and the spacecraft out to Psyche, which is an asteroid beyond the orbit of Mars. That'll be launching in a couple of years. And we've also adapted it for a lunar mission for the power propulsion element, which is the first element of the Gateway program, which is going to ultimately land the first woman and a man on the moon in 2024. So it's quite an adaptable, flexible, and reliable structure. And again, we've been using it for many years.
That sounds very exciting, and it sounds like you've got a lot going on. You're obviously doing a lot of work on innovation.
Yes, we are indeed doing a lot on innovation. Over the years, we've added, of course, 3D printing, as many people have. We're using innovative techniques in terms of manufacturing satellites, including augmented reality, virtual reality, and modern techniques of manufacturing like that.
Is this the first time you've worked with Japan?
No, actually, we've had Japanese customers for several decades, all the way back to NSTAR in the mid-90s. Recently, of course, we've had the BSAT customer. This is the second one we've done for them. We did BSAT-4a, this is 4b, both providing high-definition direct-to-home television for Japan, including several 8K HD TV channels, which are spectacular when you see them. And before this, earlier, about 5 years ago, we did 3 satellites for JSAT Sky Perfect.
Paul Este, thank you very much indeed for joining us, and best wishes now as we get close to separation.
Thank you very much.
So I was talking to Paul Estée there a few days ago, but it's incredible. They're doing some really exciting stuff, aren't they?
I think he has summarized pretty well how space is evolving. Like we've heard moon, asteroids, Mars, 3D printing, additive manufacturing, and we've heard also reconfigurable satellites. And this is also like a game changer for the telecommunication market. Reconfigurable satellites in geostationary orbit is very important because satellites can switch from frequencies. A single satellite can do this in order to diversify the services, and they can also point at very specific locations on Earth.
And here we can see we're getting close now to the moment, the scheduled moment for separation of BSAT-4b. And this is what it looks like. The satellite being... And we have the confirmation there from the Range Operations Manager. So this is excellent news. Congratulations to everybody. Congratulations to everyone at BSAT, to everybody in Japan, and congratulations also to everybody at Intelsat. Good news indeed, Damien.
Yes, it is an important milestone to have this confirmation.
And best wishes to everybody now as they take charge of their spacecraft, because of course the teams on the ground will be taking on their roles. Happy faces all around there in the Mission Control Center, Raphael.
Yeah, I mean, this is really what makes this sector very special. Like when you see these smiles, you see that these people have been working for years on their project. An operator of satellites can book its location in space up to 7 years in advance before the launch. So the teams between all the partners and the customers are really working hands in hands for several years. But this is why you can see these kind of images. And this is very unique, I think.
And it must be a good feeling for them, Damien.
Yes, it's really a specific moment for everybody, because depending on what you have worked on, even if it's months or years, at the end of this job, you see the result of your job, and when it is a success, it is always a specific feeling. And now I would like also to thank all the teams that were involved in the launch, so the people in Guiana, of course, but also all the team all over Europe on the launcher side, and of course from our customers.
Well, and I'd like to thank everybody as well. We're going to go to a film in a second, but before we do that, I want to thank these gentlemen sitting next to me, because it's been wonderful having both of you joining me here in the studio. Thank you very much indeed, Damien Gilles.
It was a pleasure, thank you.
And thank you very much indeed, Raphael Chevrier.
Thank you, Katie.
Thank you.
Really good.
And I hope you'll both join us again soon. We're going to go to a film now, because we are celebrating the 40th anniversary of the Ariane launches. In 4 decades, they have launched all types of spacecraft into all types of orbit. Let's find out more.
Ariane 1, the first launch vehicle designed in Europe, lifted off for the first time in December 1979. It was designed from the outset for geostationary launches. This made it perfect for the growing communications satellite market. Europe quickly capitalized on this opportunity in 1980 by founding Arianespace, the first commercial space transport company. The first member of the Ariane family logged 11 launches between 1979 and 1986 for both government and commercial customers. With this success under its belt, ESA quickly developed Ariane 2 and 3. Arianespace would carry out 17 missions with these 2 launches from 1982 to 1989. Ariane 3 added the ability to perform dual launches, sending 2 satellites at a time towards geostationary orbit, and this technique would quickly become the hallmark of Arianespace. At the end of the 1980s came Ariane 4, a launcher that used the same basic design as its predecessors, but was even more capable. Because of this rocket's capabilities, Arianespace captured fully half of the global market for commercial launches. Ariane 4 was retired in 2003, passing the baton to the newest family member, Ariane 5. Once again, the idea was to boost its power to handle increasingly hefty telecom satellites, while also maintaining the strategy of dual launches into geostationary orbit. At the same time, Arianespace decided to expand its family by offering launches on the storied Soyuz rocket from the Guiana Space Center. This service started in 2011. Then in 2012, Arianespace introduced a new light launch vehicle, Vega, developed by Avio at the initiative of Italy. Vega clearly showed Europe's expertise in solid propulsion. With this trio of launchers, Arianespace now had a complete family capable of handling all types of missions, whether into low, medium, or geostationary orbit. Ariane 5 has now been in operation for 24 years. It has carried out over 100 missions, including some very prestigious ones for the European Space Agency. As it hits 40, Arianespace must now tackle new challenges. Competition has grown fiercer over the last decade. Satellites are changing as well, in line with new uses. Spaceborne objects will be increasingly diversified to address a wide range of needs. Not only space probes and telescopes to help us better understand the universe, but also programs designed to make life better on Earth, with space applications that benefit everybody. The Arianespace family is evolving to address these changes, thanks to teamwork with our space agency partners. A new version of our light launcher, Vega C, is ready to enter service. Moving to the heavyweights, Ariane 6 will soon be in operation. Offered in two basic versions, it will be highly versatile. Ariane 6 could also address the smallsat market, for example, on missions shared with geostationary satellites. Its new restartable upper stage will make Ariane 6 especially effective in the deployment of mega constellations. To ensure its cost competitiveness, ArianeGroup, the industrial prime contractor for Ariane, has totally revamped its industrial organization and added innovative new processes, such as 3D printing. 40 years on, Arianespace is more than ever a key to European space strategy. We continue to deliver independent access to space for European agencies and governments, while also providing satellite operators from around the world with proven launch service excellence.
So there we have it, 40 years of successful launches for the wonderful Ariane rocket. And Stefan Israel's joining me back again here in the studio. Stefan is the CEO of Arianespace. Just to remind you, the company responsible for launching our rockets. Stefan, it's mission accomplished tonight for Arianespace.
Yes, it's mission accomplished. It has been a perfect launch, and you know that we are very proud and honored to have delivered tonight for Intelsat, for BSAT, for SpaceLogistics, and with our two partners, Maxar and Northrop Grumman, so it's a big success. This is the first time we deliver 3 satellites to geostationary orbit, so this is a premiere, as we say in French. And this launcher was the most capable we have ever launched, with 10 tons available for the satellite. So many innovations tonight for us.
A lot of firsts tonight. And of course, every space program involves hundreds, sometimes thousands of people working together, sometimes for many years. Who's made tonight's mission possible?
Yes, so regarding what the launcher has accomplished, we must thank tonight many partners. We must thank ArianeGroup, which is Arianespace mother company, and which is a prime contractor of the launcher, delivering the launcher to Arianespace at liftoff, what we call H0. We must thank CNES. CNES is a design authority of Ariane 5, and CNES is our daily partner in CSG, and you know that it has been very hard to work in CNG during the COVID conditions, and we must thank our partner in CNES CSG for that. We must thank ESA, which is at the head of the overall program of Ariane in Europe, and so a big thank to ESA, and for sure we must thank Arianespace team who have worked as hell to make this success possible tonight.
And we had to be a little bit patient, didn't we, for the launch tonight, but we got there in the end.
Yes.
Thanks, Stefan. So let's see if we can go over to Luce now. Luce Fabregat in the Mission Control Center at the Guiana Space Center. We're hoping that we can join her because she will be, of course, with the teams there. Luce, what's the atmosphere like?
We are, I think you can look on our faces, we are really relieved and very happy and if I may, Stefan, I would like to say a big thanks to all the teams. I know that people have been spending weeks and weeks here and working tirelessly to achieve this launch. So thanks a lot to everybody. And now the journey is over for the launcher, but the journey is starting for the satellites, and they have already acquired the signals, the first signals from the two ones we have separated for Intelsat, Galaxy 30 and MEV-2, and maybe they have already they are close to acquire the signal for BSAT-4b for Japan. So everything seems fine. Then as soon as they have the signal, they will start the operations, first having the energy, and so for that deploy the solar panel towards the sun, and after that start the propulsion sequence. And they all have chemical propulsion, so it will take a short time for all of them to get to their final slot in orbit, and we wish them all the best for their lives.
Thank you very much indeed, Luce, for taking the time to come and talk to us. And our very best wishes to all the teams now as they take on their satellites, as you say. Luce Fabregat, thank you, and good luck for your next operations. So, Stefan, today marks the first launch since the resumption of activities at the Guiana Space Center. What's next? When's the next launch?
Yes, so the next launch will be with our dear Vega. It will be on September the 1st. It's a very important launch because it is what we call the proof of concept of SSMS. We will have 53 satellites on board for 21 different customers. So it will be a very exciting mission, and it will be September the 1st. And I really want to thank all our teams in Guyana. Luce has mentioned the fact that the teams have been working for months now. They have arrived in Guyana at the end of May, so we are now mid-August. So you can imagine that with our customers, with our partners, how we have had to work to make this success tonight. So thank you to all of them. And we will be back September the 1st with Vega, and it will be a great event as well.
Great. Well, thank you very much for joining us, Stefan. And thank you for joining us. We'll see you back here again on the 1st of September for that launch. Until then, I hope you'll join us then. And until then, from Stefan and from me, goodbye.
Goodbye.